Hello students, this is one of the question which is given to me as a doubt by one of the students from YouTube. The topic is from modern physics, and this is a question in which the light is being incident from the top this way, from the top, and this find the force exerted on the cone due to the light beam. See, let me tell you one concept before that. When there is a whenever there is a surface like this, there are two cases. One, when the light is coming like this, it has the intensity I. Then c is the speed of light. Then the force exerted when this is refracted, when it gets into it, the light incidence is incident into it, and then it does not move back, it does not get reflected. In that case, we know that there is a result in the modern physics. The pressure exerted on the wall is given by I by C. And when this is no reflection, and for reflection, the pressure is 2I by C. These are the two results that you should know. Now here in this case, this question is actually very easy. When in the first case when there is no reflection, in that case, because see here, if you see, the ray of light is coming like this, and the effective area, if you see everything properly, the ray of light which is coming is perpendicular, so effectively it will be striking these points. And if you take, doesn't matter, height is not a matter. If you take the projection of these, the projection of these on the horizontal, means they are actually striking the whole circular area, this circular area. So, and we know when there is no reflection, in the first case, pressure is equal to I by C. This is the force divided by effective area on which this is acting, this is incident upon. That's pi into r square, the radius of this, the lower surface, is equal to I by C. So the force exerted is equal to I by C into pi r square. He gave the result also. This is the second result when there is no reflection. Here is the no reflection case, and first is the reflection case. And in the case of reflection, pressure is equal to 2I by C, and force is, the effective area is pi r square again. So it will be 2I by C. So F is, in this case, is 2I by C into pi r square. This was actually very easy question. Did not need any help. That's why I said there is nothing involved in this question, so there was no need of solving anything. Yes, you could have done mentally also. Very easy question. Now coming to the next one, which he has asked. Now let's see the second one. This is the second question. Electron accelerated by potential V are diffracted from a crystal. Electron accelerated by potential V are diffracted from a crystal D1. This is 30 degree. V should be about. Acha. See, this is a question of diffraction. In this diffraction, we know N lambda is equal to 2d sine theta. we have to actually equate the path difference with n lambda. So let's draw the diagram first. So diagram of the diffraction. This is this. This is diffraction pattern. This is the distance d between the two layers. The ray of light has come in this way, and then it got reflected. In the same way, I can draw another the ray in the same way here, and again this ray. Okay. This distance is d. This is a diffraction pattern between the two surfaces, and they have given the angle of incidence I is 30 degree. Now this is 30 degree means again this is also 30 degree. We have to find out the path difference. Means this distance plus this distance is the path difference. If this is 30 degree, this is 90 degree, this should be 60 degree. And this distance we know. So x will be equal to d sine 60. Here also same thing. This is 30 degree. So what? This is 30 degree. This is 90. This is 60 degree. Same thing, everything. So the total path difference delta x is 2d sine 60. It is actually 2x. And in the diffraction, this became the same. This is actually derivation of how we find out the path difference. So 2d sine 60 here will be equal to n lambda. And let's have this for n is equal to 1 for first order. This problem will solve out to be 2d sine 60 is equal to lambda. 2 into distance is 1 angstrom, which is 10 power minus 10 meter, into root 3 by 2. So lambda is coming to be root 3 into 10 power minus 10. Now coming to the electrons accelerated by potential V. You know, when an electron is accelerated by the potential V, difference B, it gains an potential energy here. That's E into V is equal to half mv square, where V is the velocity. Okay, and this velocity this kinetic energy that it has is what is given by this lambda, which is hc by lambda. So this E into V, I can write E into V, potential difference is equal to h into c by lambda. So E is 1.6 into 10 power minus 19 na, in the equation. Well, lambda is equal to h by mv, we have to write. Because we do not know now. This is the total energy that they are asking. So lambda is there, we have to find out its kinetic energy. Lambda is equal to h by mv. So your velocity will be h by m into lambda. So E into potential difference V is equal to half into m into h square by m square lambda square. Or you can do one thing. V is equal to h square by 2em lambda square. H square by 2em. This is the de Broglie equation I'm using here. Because see, we do not know now this is equal to h nu, because see, we do not know about that. This is equal to h nu because what is the work function, all those things we do not know. That's why. So this potential difference will be equal to this. This is 6.625. What's the value of h they have given? It's 10 power minus 34 whole square by 2 into 1.6 into 10 power minus 19. Mass of electron also they have given, or what? 9.1 into 10 power minus 31. 9.1 into 10 power minus 31. Lambda square is 3 into 10 power minus 20. Now let's solve it. Let me use the calculator. It will be quick. 6.62 into 6.62, it will be 43.82 into 10 power minus 68 divided by 2 into 1.6 into 9.1 into 3 is 87.36. 10 power 19 plus 31 plus 20, 17. It's 43.82 into 10 square by 87.36. So it will be 4382, 87.36. It will be nearly 50.16 volt. So your answer will be approximately 50 volt. This should be your answer. The catch here is, earlier what I was using, what I was trying to do, I was about to apply this half mv square is equal to h into nu, hc by lambda. That's wrong, because we do not know now. It's not a photon, it's a particle, and we do not know if the kinetic energy of this sort is striking. Then after striking, how much work function of the material is there, it's not given. So we cannot just apply that equation, that photoelectric effect equation, h nu plus that h nu minus work function. We do not know work function. So in that case, we have to change the value of lambda that we have got in the kinetic energy form, and then we have to apply here, then we'll solve the equation. Okay, this is how we solve this. Okay, let's end this. Only these two doubts were given to me by the student. Hope you have understood. If you have any doubt, you can ask me in the comment section.